This is Common Core State Standard Support Video in Mathematics. The standard is 6EEB5. This standard reads, understand solving an equation or inequality as a process of answering a question. Which values from a specific set, if any, make the equation or inequality true? Use substitution to determine whether a given number in a specified set makes an equation or inequality true. One fundamental idea here is that of solving an equation. The expectations of this standard regarding the solving of an equation should not be new to students due to previous exposure and practice in earlier grade levels. If you do a search of the standards using the term equation, it's going to result in multiple hits in grade levels K through 5. For example, there's standard 108D8 that deals with equations, determining the unknown number that would make that equation true. In third grade, there's standard 30A4, and again, it deals with determining unknown numbers that would make the equation true. Back in second grade, you had standard 2MDB5 that dealt with word problems, and again, students were expected to use drawings or equations with a symbol for the unknown number to represent the problem. In third grade, a similar standard, 308D8, dealing with word problems, and again, using equations with a letter to stand for the unknown quantity. Standard 4NFB3D deals with fractions, and again, using equations to represent a problem. Standard 4MDC7 deals with angles, and there you also have equations involved. In the previous grade level, there's standard 5NFB6, where we're dealing with multiplication of fractions, and again, students will be using visual fraction models or equations. Now, in the same grade level, grade 6, you have a standard that's in the same cluster, 6EEB7, that deals with solving real-world and mathematical problems by writing and solving equations in the form x plus p equals q and px equals q for p, q, and x being non-negative rational numbers. Notice that we're dealing with non-negatives here, so we're not going to be dealing with any negative numbers. Now, there's a focus here on this idea of solving an equation being a process for answering a question. And this question is, what values from a specific set, if any, make that equation or inequality true? What's a little different here is this idea of the values being from a specific set. Typically, this is what we deal with. We just jump in and we solve equations, and we're looking for values that make the equation or inequality true. So for example, let's say we had this basic equation, what plus 8 equals 12. In mathematics, it's typically assumed that the set of numbers we have to choose from for the solution is a set of real numbers. And at lower grade levels, the set is usually the set of whole numbers. So after a while, teachers and students lose sight of the fact that there's a given set of numbers that they can choose from for a solution to an equation or a problem. Again, we lose sight of that, though, that we actually have a specific set to choose from. Typically, okay, we're solving this basic equation, and the solution set will be the set of whole numbers. But what's different about this standard is now we need to deal with situations like this, where let's say the set of numbers that we can choose from for the solution is just these numbers, the whole numbers from 0 to 10. Then, of course, we know that the answer is 4. Let's change the context. This time the set of numbers from which we can choose is just these numbers, 6, 7, 8, 9, and 10. Now, we figured out that the answer has to be 4, and that's not one of the numbers in our set, so there's no solution. So that seems a little strange. It's something that students will need to get used to, but this was our context. We only had these 5 numbers to choose from, and the correct solution, the 4, wasn't one of them. Let's try a slightly different context. This time, the numbers that we have to choose from for our solution is a set of odd numbers. So there's no solution. Again, this whole idea of our solution coming from a specific set is something new here that students will need to get accustomed to. This last part of the standard talks about substitution, using that to determine whether a given number in a set makes an equation or an inequality true. At this level, this would be a typical equation, a simple addition equation like n plus p is equal to m. So let's say the equation was n plus 7 equals to 15. And the set of numbers that we have to choose from for our solution would be the whole numbers from 0 to 10. So the question here is, what value for n will make this a true statement? So if we use substitution, we plug in numbers, and we determine that 8 is the correct solution, and it is part of our set that we had to choose from. Let's try a similar problem, but subtraction. And let's say the problem is n minus 15 is equal to 16. This time we have a small set of numbers to choose from, 1, 8, 11, 24, 31, and 43. So our solution set is just these numbers, nothing else. So the question would be, well, what value for n would make this true? Students might look at this and see that, well, we're subtracting, there's 15 and 16. Well, the difference between 16 and 15 is 1, so the answer is going to be 1, and it is part of our set. Now, if we pay attention, the standard says to use substitution to determine if a number makes an equation true. If the students just jump in and try to do the calculations in their head, well, they might make a mistake like what happens here. Apparently, this student did not follow the standard. They did not use substitution. They just figured, okay, the difference is 1. Now, if we do use substitution and we plug in the 1, we'll notice that, hey, this isn't correct. That doesn't come out to be 16. If we follow the process and we use substitution, we will discover that, whoa, 31 is the correct answer, because 31 minus 15 is 16. Let's try a multiplication type of equation. A times b equals c. Specifically, let's try 7b is equal to 56. And the set of numbers that we have to choose from are the whole numbers from 0 to 10. And the question is, what value for b will make this a true statement? Use substitution to determine which one works. And we see that 8 works because 8 times 7 is 56. Let's try a division example. And let's make this problem 6 divided by 1/2 is equal to c. The numbers that we have to choose from are just these few here, 0, 1, 3, 6, 9, and 12. And of course the question would be, what value for c will make this a true statement? Well, some students will just jump in and figure, well, it's got to be a 3. But wait a minute, that's not correct. I thought 6 divided by 2 was 3, so that can't be the right solution. Now we use substitution and we come up with the correct choice. That is a 12. It was part of our given set for our solutions, and 12 did work. So that is the correct one. So at this grade level, these would be the typical types of equations that students would be expected to solve. And again, the difference is that they would be given values from a specific set to choose from to see what solution would work and make that a true equation. Dealing with equations, and these are typical examples again of what we will use at this grade level. If the set is understood to be the set of whole numbers or the set of real numbers, that last statement about using substitution is not as applicable, because subconsciously that suggests that students check their answer for correctness. The tendency here will be to use substitution not for finding the solution, but to check for correctness. But students need to get in the habit of using substitution to actually find the solution.